so much of sports we have experience. Every year it is increasing that way. Our visitors are also suffering. Since tourists are very less in number, and everybody has the same answer that there are very few people who are coming to Mumbai this season. So all these reasons are playing role for this. So Anandita, you can let us know that when you want to start.
Sir, we can start now, sir. Yes, yes. Participants have joined. I think we can start. And we are live on YouTube and Facebook also, sir.
Okay. Okay, then let me start. Sir, just for your introduction, I'm Umesh Kumar, Director of Nehru Science Centre. I'm privileged to have you with us. And now I'm going to all our audience, welcoming them. I think this is the season's, I should say, new academic year first lecture that we are organizing, starting with National Technology Day, which is very, very significant. So when India is concerned and nuclear power is concerned, as we all know that National Technology Day is celebrated on 11th May every year. And this is because on this particular day, we had tested three different technologies, and one of them was the coconut gold test in 1998. In fact, at that time we faced a lot of problems, but somewhere I read, like I think Pure Tolstoy said that if you want peace, prepare for war. And very good examples nowadays that what is happening in the world around. And in our mythology also, in our setup, we say that कि यदि आपको महाभारत रामायण को समझना है तो महाभारत पढ़नी चाहिए. If you want to understand the Ramayana, then first you should read Mahabharata. So that these are the two things perhaps we say that when we had nuclear test in 1998, we faced a lot of problems. But then we overcome because problems provide you opportunity, challenges provide you opportunity. So in honor of that legacy, Nehru Science Centre is privileged to host a session highlighting India's scientific advance. Basically, this particular thing is a acknowledgement or recognition to the vital contributions of our scientists, engineers, innovators. And on this very, very special occasion, today we have with us Dr. Sai Baba, who is a distinguished nuclear scientist, an academic leader, and expert in science communication as well. With decades of experience in India's nuclear energy ecosystem, Dr. Sai Baba formerly served as Director of Resource Management Group at Indira Gandhi Center for Atomic Research, short form IGCAR. They played a pivotal role in advancing our indigenous nuclear capabilities. Frankly speaking, we have signed several agreements from the government of India, where one of them is we need to reduce our carbon footprint, and nuclear is one of the best answers in recent time, whatever we see. Dr. Sai Baba's influence extends globally.
Umesh, she was telling that today is a very important day, and I'm going to talk about the topic which is important for this country. Before that, I think, Dr. Umesh, so today is a special day of, the technology we are celebrating, and very nice cartoon made by one of my collaborator, Lima Jaiswal. I hope she's joined today's talk, and it's very nice cartoon which we made. And actually, this National Technology Day is celebrated in a month of May. Several things happened. One is the Operation Shakti at Pokhran, is on 11th May. It's also India's flown the first indigenous two-seater aircraft made by NAL in Bangalore. And also Trishul missile was, final testing was done. It was introduced into the services. So to celebrate the scientific achievements and honoring the technological innovations, then the Prime Minister Atal Bihari Vajpayee ji announced May 11th as the National Technology Day, and that's been celebrating. Incidentally, yesterday, DRDO has flown a missile which can target multiple targets at the same time by the same missile. So very significant advancement that's happening. I do write on several public topics called Toon Logs. If some of you who are interested should visit these sites. Essentially, Technology Day is empowering society by harnessing the technology. That is the motive of these celebrations. Well, I think we all have dreams, and India also has the dream, the Vikasit Bharat, and this is one of the cartoon competition. One child draw what India will be in 2047. You can see very impactful. She said no poverty and peace, corruption, education, communication. Very significant, impactful cartoon. I think which has won some award too. I thought I should show this. But then we want India, which is economically developed, scientifically advanced, and militarily strong, and there is security in terms of energy, water, food, health, environmental. These are all our dreams if you want to have Vikasit Bharat. But what is the reality today? Today, India has 77% of the population have smartphones. This number may be old, it may be a little higher than that. So we're very happy about this progress. But then at the same time, you would see more than 330 million Indians still lack access to safe water. This sort of a contradiction which the country is seeing. So if you want to realize the India of our dreams, it is possible only when India becomes a knowledge-driven economy. And it should have the ability to develop new knowledge and also appropriate knowledge developed in other countries. And it's all should be R&D-led technology development. And our strategy should be technology maximization and time minimization. That is how we will achieve progress and realize the dream of Vikasit Bharat, and by the time frame which you explained. When you take the society, the pillars of development are energy, environment, and economy. We need energy. We need to have energy independence. And also we should promote efficient utilization of this energy. While doing so, we need to conserve the environment, and if not, at least minimize the impact of the development. And all these things have to be economical and enhance the availability and affordability. At the top of the thing is the energy availability. And these are all because we want to enhance the quality of life. And energy defines the index of quality of life. And when it comes to energy availability, the world average is around 1300. World average is on 3500 to 4000 kilowatt hour per person per year, whereas India has about 1300 is what today we have. So that means a long way to go for us to reach the world average. Forget about the advanced countries. There's something called Human Development Index. This Human Development Index is a combination of several factors: economy, education, health, and all. What this plot shows is wherever energy that is becoming available more, the Human Development Index is going to be very high. Then where are we now today? We are now somewhere here, 0.6. our energy is about 1300 or so. And where you want to be, if you want to reach a level at 0.9, the energy that is required should be at least 4 to 5 times of that. That is the challenge which we are having in terms of making energy available. Now, what are the challenges? One is we need more energy. When you need more energy, we are also telling we should reduce the emissions. It should be cost effective. And more importantly, public should accept it. And these are the challenges of enhancing the energy input. The Niti Aayog come out with a government view and said, our focus will be access to energy at affordable prices, improved security, greater sustainability. In the current conflict that's going on in the Gulf, you would see why we are telling about security, improvements of security is important. There are several sources of energies, be it solar, wind, hydro, geothermal, hydrogen, fuel cells, battery storage. Multiple options that are available for us. When it comes to multiple sources of energies, if you want to have low greenhouse gases and low air pollution, it is the wind and the nuclear are the ones which are lowest in terms of greenhouse gas emission and also air pollution. Now, just quickly see what are the other sources of energy that are available. One is the hydro, is very good, large scale displacement, but then it's very good for energy production as well as for agriculture. But there are societal issues in terms of large scale displacement. And unfortunately, we almost reached its potential, no more potential to explore when it comes to hydro. And when it comes to wind, the offshore technology, storage, floating platforms, wind mapping, several things that are happening when it comes to low speed battery there. And when it comes to solar, everywhere solar is there. Everybody thinks solar is good. Yes, it is good, whether it's photovoltaic or thermal. But the problem is we have to address the transmission and distribution problems, economics, storage. Nobody is talking about life cycle management of solar panels. It becomes a huge problem after some time when the solar panels needs to be displaced. Biofuels is a good other alternative. It's a conflict between food and energy for a developing country or for an aspiring country like India, where a lot of people, food security becomes very important. And hence, every energy has its own challenges are there. So there are some direct and indirect costs of renewable energy integration. We should create a green energy corridors, interstate or interstate, to carry out surplus from RE. Suppose in Karnataka, the green energy is created more, then you should be able to transmit to a state where the energy production is less. And another biggest challenge is the cost of standby capacity. When you want to use these renewable energies and they are not available, what will you do? And if they are available, what will you do with the capacity you have added? This is where the standby capacity is a problem. Meet demand when solar and wind power reduces. This is where the standby capacity will come. Cost of flexible power generation. Suppose I have a coal power plant or a coal power plant, and you say you don't operate now, you operate tomorrow. That means you're cycling the entire machinery. So this flexible power generation can be a big challenge for the technology. I just try to look and see what world is doing. If you take Germany as an example, Germany is one country which has gone real into renewables. They decided against nuclear, and you can see they're almost like 56% of their energy is coming from renewables. Nuclear is almost become zero by the decision making to be there. So this is one country which solar seem to be renewables and solar have become very. When it comes to France, you can still see about what used to be 71.7% of the consumption energy is produced from nuclear. It now reduced to about 65%. And so what I want to say is when it comes to energy generation, still majority of the energy is coming from fossil fuels, and about 79% of it comes from fuel. See, this is where I think when we look into energy, when you use a car, the diesel, you feel dirty about it, but then you move to electric and you feel very clean about it. it's very good to move to EVs. But then, where is the energy is coming to this electric vehicle? Where is the electricity is coming? If you do not address the source, that means we are only shifting the burden from the car to the power plant. And 85% of emissions are energy related, and out of energy emissions that are coming out, 95% of them are carbon dioxide. So this is the situation what you're facing as far as the energy utilization is concerned. In the last 10 years, per capita energy consumption increased by 50%. Just imagine the type of requirement we are having. So that means we need to work towards reducing the carbon footprint for each individual. This is a goal set by each individual. Now, whether we like it or not, world continues to electrify. An analysis says even beyond 2050 or 2060, coal will continue to play a role, maybe about 30% or so. Maybe the gas will dominate, oil will come down, nuclear is remain stable. Hydro, I told you, it's almost reached its potential. Maybe the renewals will start increasing. This is what is the prediction for the energy outlook for the next 30, 40 years. So we need a source of energy which can replace this coal, which is almost 30% of it right now. So if you nuclear deployable in large scale to meet the base load, I think this is something which I want to repeat and say, if you want to replace something coal, the base load requirement can be met by nuclear. And perhaps at the present, it could be the only such alternative for the world. Other than going to nuclear, there no seem to be an alternative for replacing coal. Now I'll do a little bit about high school physics. We have certain nuclei, which we call as a fissile material, and uranium-235 is one such naturally occurring fissile material. Upon interact with neutrons, it absorbs the neutron, becomes a compound nucleus, and then it gives two fission products. But you would also see in the depiction here, every neutron that is absorbed, it gives you multiple neutrons which are emerging. And typically, on average, 2.5 to 3 neutrons are generated. And these neutrons are what is used for sustaining the nuclear reaction. Unfortunately, if you take uranium, the only fissile material that is naturally available is uranium-235, which is only 0.7%. And this uranium-238, which we call as the elder brother, is 99.3%. And what the uranium-238, what we call as the fertile material. A fertile material is the one which, upon interacting with the neutron, will undergo a chain nuclear reaction, gets converted into neptunium, and then gives you plutonium by when you put in. That means uranium-238, upon interacting with neutrons, becomes a compound nucleus, undergoes changes, and finally gives you plutonium-239, which is a fissile material. So that means you have uranium-235, which is fissile, and plutonium-239, which is fissile, which can be generated in a reactor. When it comes to thorium, thorium is monoisotopic, and it is a fertile material. That means it cannot undergo fission by itself. So when you put in a reactor, just like uranium-238 to plutonium-239 conversion, thorium-232 will get converted into uranium-233 in a reactor. And uranium-233 is a fissile material. So but we have three fissile material known: uranium-235, plutonium-239, and uranium-233. Now, I would only say a little bit shift and say, what is the potential? If I use 1 kilogram of coal, I generate about 3 kilowatt hour energy. But if I use 1 kilogram of uranium, you can see you can generate as high as a 50,000 kilowatt hour. That is very high potential source of energy. In terms of a nuclear plant, let's say I have a 1000 megawatt power plant. If you want to run this 1000 megawatt plant for 1 year, you need about 26 lakh tons of coal. But when it comes to nuclear, in a PHWR, probably you need only 200 tons of uranium. And if it is used in a breeder reactor, we will need much less uranium, that is equal to 1.3 tons. And just for an example, if you want to have 1000 megawatt reactor, equivalent energy to be produced, you may need about 20 to 50 square kilometers of solar power. That means for one city of Mumbai, you want to produce the solar energy, you need to have another adjacent city, which is just to produce the energy. Same thing true with the wind also. Typically, when you talk about nuclear, people always have worry about waste. Every coal plant, because about 10% of the coal is ash, it is retained as ash. And you can imagine in 1 year, about 22,60,000 tons of ash is generated. When it comes to nuclear, it's about 250 kilograms of plutonium, which we don't want to call it as a waste, maybe 30 tons of high-level waste, and about 800 tons of low-level waste. Just because of the high potential of nuclear, the fuel requirement is less, and hence the waste that is generated also is less. What is the situation worldwide? Today we have about 438 reactors that are operating, generating about 400 gigawatt, about 9% of the total energy that is produced is through nuclear. But the problem with nuclear currently is that there are several reactors which are old now. There are about 30%, 67% of the reactors are more than 30 years old. And the other things are little higher in age. That means they are all reaching their aging. Many of the reactors are getting aged. So we need to address this issue if we want to sustain the energy contribution from the nuclear. And in 2025, 4 reactors have been added, 4.4 gigawatt of new energy has been added to nuclear. Just for information, United States, which has 93 reactors operating, 19% of the energy comes from nuclear. And when it comes to France, today 56 reactors are running, around 65% of the energy is what is generated from the nuclear. And there are 78 reactors are under construction, almost contributing to 78.9 gigawatt electric. And you can see China is there everywhere. I think whatever you say, China will always be there. And China is one of the maximum number of reactors that are coming forward by India and Russia. So that means nuclear is there and nuclear will be there. And they wanted to multiply by adding some new reactors. So what I do is I just spend some time, maybe a few minutes, 1 or 2 minutes to explain the 3-stage program of India. That the Homi Jahangir Baba, the father of Indian nuclear energy, envisaged this much before, and taking into consideration the Indian situation. We have less of uranium and more of thorium, and hence he envisaged this 3-stage. In the first stage, in thermal reactor, you put uranium-235 and generate power. And also the depleted uranium, because if I showed you 93.87% is 98.3% is about the uranium-238, and that will be in the depleted uranium. The plutonium that is generated in thermal reactors is utilized in a fast reactor, which is plutonium-fueled fast reactors. It's a breeder reactor. That means more fuel is generated than consumed, and hence you can sustain the reactor for its lifetime. Then you also get power for this. You introduce thorium into these fast reactors, then you will generate uranium-233, and this uranium-233 and thorium put together will run in uranium-233 breeders. That is in the 3rd stage of program. Many people may think, since we have more thorium, why can't we utilize it early? What I want to say by 3-stage program is the uranium to plutonium conversion can happen in thermal reactors as well as in the fast reactors. But in the thermal reactor, the conversion is not efficient. That is efficient in fast reactor. In the same way, conversion of thorium to 233 is faster, is more efficient in a fast reactor. And hence, you need to go through this 3-stage program if you want to effectively utilize the potential of thorium. And that is what is the 3-stage program is all about. The best part of it is that the nuclear power is a combination of several things, starting from mining to designing, constructing, operating the reactors. And India is self-sufficient in the fuel cycle, starting from the fuel fabrication to the structural materials to fabricating the fuel bundles. India has the indigenous technology and self-sufficiency in the fuel cycle. Self-sufficiency is also there in fuel reprocessing, waste management. That means we are only closing the fuel cycle. Closing means You put uranium in a reactor, produce power, take it out, separate the remaining uranium, separate the plutonium that is generated, and make use of it for refabricating it. Now, how are we doing it here? I mean, I think how has been our reactors performing? You know, the continuous operation of nuclear power plants, you can see the number of times which are operating for more than 300 days is there increasing, and multiple reactors are operating for more than 1 year. And as the years are passing, the number of reactors that are operating for more than 1 year is increasing, indicating that it is the mature technology. India has also set a world record. Its longest operated for PHWR was Kaiga Power Reactor, 962 days. I think subsequently another reactors done beyond that, but I think we could achieve this for the first time at that height. Now, our reactors are operating well. What about what about radioactive emissions from nuclear power plants? And what I showed here is what is the natural background, about 2,400 millisieverts per year is natural background. And the regulatory body ARB set 1,000. And you can see all the reactors, the radiation emission is far, far less than what is permitted by ARB, showing that efficient management of the nuclear power plants. And somehow people should also be aware that radiation is there, natural radiation is there. This IRMON data, which I'm showing you here, it shows you that there's so many places where the radiation backgrounds are higher and they are not necessarily connected to any nuclear power plant being there or nuclear facility being there. Now you can see that, and how the evolution of technology happened. We started with thermal reactors and we went on to thermal reactors. Based on the research done in thermal reactors, we have gone to a commercial reactors, started from 220 we went to 540 and 700. We standardized now 700. We are also importing the reactors and trying to operate them. So these timelines have been expansion and economy of scales over a period of time. While this mastery is happening, we also matured fast, reprocessing the closed fuel cycle for getting ready for the second stage. And nuclear reactor, and when we are thinking about expanding the size or increasing the size, there's a lot of interest in making the reactor smaller. Now, no discussion on nuclear would happen without discussing about small SMRs. And so there are issues. Maybe it requires a separate topic altogether about how do we approach SMRs. But that's how we want to take the reactors into smaller ones. And you all must have read in the papers in the recent month back or so, India achieved a breakthrough. The fast breeder test reactor, which is there at Kalpakkam, is a 40 megawatt thermal reactor. It's a sodium cooled loop type reactor, which is a test reactor, but it also produces power. It fuses a very unique fuel, uranium plutonium mixed oxide. It has been running for more than 40 years. And based on all this expertise which is there, the prototype fast breeder reactor is being constructed. Very happy that about a month back it gone critical. That means its sustained chain reaction has been demonstrated. It uses a mixed oxide fuel. It's a pool type of reactor. Essentially, these are serving as a platform for working on FBR, fast breeder reactors, and providing operational experience and also testing the new fuel types. If you recall my 3-stage program, which I showed a while ago, this is the beginning of the second stage of the reactor. Just to be ahead, we also have a reactor at Kalpakkam called Kalpakkam Mini Reactor, which is functioning from 1996 onwards. A very small reactor, but it uses uranium-233 as a fuel. Probably for a long time, it's the only reactor in the world which uses uranium-233. Recently, another research reactor has been added by, I think, in China. So it is a very uniqueness of all the 3 stages are different being demonstrated. This is like a gaining experience of using uranium-233 as a fuel. It's also used for neutron radiography. I will mention it a little later. And a lot of advancements are being talked. There's always impatience about thorium. So early utilization of thorium. That's why advanced heavy water reactor is being planned, is designed, is now going through regulatory clearances. Maybe it will happen soon. The department is also working on high temperature reactors, both for hydrogen production with electricity and desalination, accelerated event systems and advanced thought about, and fusion based systems. These are all things which are being done for the futuristic development of advanced nuclear energy systems. Now, what is the India's immediate target? You can always say you're telling multiple things. What is our target? India's government has set a target that we will increase the share of nuclear energy to 10% of total electricity. The world average is about 9%, and we would like to reach that level. We have to standardize nuclear power plants because we have PHWRs, we have LWRs, we have FBRs, and India also set a goal of 100 gigawatt by 2050. So what is being talked about is serial production of nuclear equipment and capacity built up in the industry. That's how we can do multiple reactor construction can happen. So you will have PHWRs with indigenous uranium and also imported uranium and put on these reactors under the IAEA regulation, and then we also have LWRs which are imported. Then what we can do in this under these safeguards, the LWRs will uses enriched uranium. So the fuel coming out of LWRs can be utilized as a fuel for PHWRs, because PHWRs are natural uranium fuel. So this is how it is being envisaged, that when you import an LWR with the right to use the fuel, you will be able to utilize it in a PHWR, so that enhance the nuclear power. And a lot of discussion is happening on private sector participation. The private sector participation so far has been mostly EPC part of it. Government registration is telling expand the nuclear energy sector, private sector participation. It's already invited major enterprises like Reliance, Tata, Adani's, and Vedanta to see whether they have interest. And this NTPC taking big steps. You must have read in newspapers that NTPC already put up a proposal that they would like to develop 2 or 3 sites with nuclear power plants. Jindal, Hindalco, all these people are coming forward for replacing their the captive coal plants into nuclear power plants. That's where the interest in the small modular reactors also coming. The operational framework for private sector participation is a question which is being discussed from the industry and the government. We need to establish public-private partnerships like NPCL and the NTPC. Maybe Niti Aayog said we need to advocate the promotion of SMRs to encourage private sector participation. And these are all things that are happening. Shanti Bill has been enacted. Now Shanti Bill enables, empowers the private entities to enter independently for nuclear energy generation. So either you collaborate with the government agency or you can do it by yourself. So, but then there's a big challenge which people have not discussed much is the skilling. We need to have skilled workforce if you want to meet your aspirations of having 100 gigawatt by 2050. So we started with 220, 540, 700. We had started importing reactors at 1000 megawatt. The EPR, the Areva is telling about to buy 1650 megawatt. And then suddenly we are telling we will get into small reactors, and micro reactors are the ones which are being discussed extensively and to put to use. Indigenous, what is the plan for the government? India has come out with a plan that we develop 200 megawatt reactors, 55 megawatt reactors, and 5 megawatt reactors. The 5 megawatt is a micro reactor, high temperature gas cooled reactors. This is what government has come out with the mandate for the department to work on these 3 reactors. When it comes to micro reactors, it looks like small and portable. You can always build somewhere, come and install it. It will enable rapid deployment, operate for years without refueling. This is another thing which they are thinking in terms of, it's like fill it, shut it, and forget it concept. Put it inside and maybe operate for 10 years. Then take it back to the factory and replace the fuel element. So there are multiple uses: power generation, process heat, desalination, maybe hydrogen production, and competing with where you cannot reach out, in border areas or in remote areas. These reactors can be very used in deployed in the military installations, deploy in locations recovering from natural disaster. Suddenly, a natural disaster happened, maybe such microreactors can go there. In space missions also, they can happen. So there are challenges, the manufacturing challenge, economic viability. Normally, the sense says larger the better. Now we are telling in terms of smaller cost per megawatt, capital cost. These are all challenges when you want to reduce the size of the reactor. But of course, where are the sites now? Reduction in the size makes it mobile, easily deployable. The availability sites now you have to between SMRs and the normal reactor. There should be paradigm shift that you want to have it in your backyard, so that with the energy enhanced safety. Now, all this while, I talked about the energy security, why you need clean energy, how it can help climate change, and how nuclear is progressing in our country, by in what way we are taking it forward. And now I'll shift my discussion to about the other uses of nuclear. Nuclear doesn't mean only nuclear reactors or nuclear bombs. I think these are multiple things, starting from water desalination to food agriculture, healthcare, transport, industrial uses, space exploration. And you can see that a lot of research is done by under radiation-induced mutation. Several crop varieties have been. These crop varieties are high yield. They're also resistant to stresses and improved quality. You can see the happiness on the face of this woman who is carrying the yield of these groundnuts. And you can see that, and you can also work in rice, in mustard. So a lot of work is done in terms of genetic improvement of the food products. You all must have heard about radiation processing. This radiation processing is very useful for preserving the food products, starting from inhibiting the sprouts, be it onion, potato, ginger, or garlic. Shelf life extension of food like chicken, meat, or fish, whatever fish. Insect disinfection, like cereals and pulses. Radiation processing will have multiple advantages. Of course, it depends on the purpose, how much of dose has to be given, low, medium to high. And of course, now there are units that are established for food processing. Just like you go to the airport, give your luggage, and then it gets scanned and comes out and picks up and goes. The same way, you can see that food items can be scanned. It's there in Vashi, Navi Mumbai, and also in many other places it's coming. We also should know the food processing is very important. Radiation processing is very important if you want to export food products. Till recently, you cannot export Indian mangoes to US. Our friends and relatives would be missing Indian mangoes there. Today, with this radiation processing, they can export these food products, and our friends and relatives enjoy the Indian mangoes as much as we enjoy. But also gives a market for the farmers. It also enhances their income levels. Radiotherapy, I'm sure if somebody is identified with a cancer, you need to treat with radiation. Babatron is an indigenous telecobalt mission, almost built at a very low cost, and it is being made available for medical treatment. Of course, sterilization of medical products is another big challenge, and you can always have this radiation processing for disinfecting the medical aid, sterilizing the medical products to be there. Of course, we also, based on the technology that is available, and they developed a tele-ECG machine. There's no radiation source in this, but it's a technology demonstration which helps a lot for people living in the remote areas. And very commendable work is being done by Tata Memorial Centre in providing affordable cancer care. They are also working on National Cancer Grid, linking about 108 locations across the country. One of the largest cancer care networks in the world. Grid connects cancer centers, research institutions, patient groups, and NGOs. In fact, they also have there's no record of the cancer patients here. A registry for cancer patients, I think, is developed. A lot of radiopharmaceuticals are built by BRIC It's a DA, one of the DA institutions. These radiopharmaceuticals are made, separated, and prepared in a way it can be supplied to the hospitals. Each of these isotopes have a particular application, and now all these things are being done by this bridge. For industry, it is used extensively for radiography, starting with X-ray radiography, gamma radiography, or neutron radiography, and it's very extensively used for quality control. And neutron radiography used in multiple applications. There's one of the applications which is very interesting is for the pyro devices used in the space program. The pyro devices will have the pyrochemical filled in it. If there's any gap in the pyro device filling, it will lead to a failure. So every pyro device that is there in a spacecraft which flies is done neutron radiography to ensure that they are properly filled. And this work is done at Kamini, the small reactor which I showed you at Kalpana. See, when large power plants are there, and sure, being in Mumbai, you would have seen large chemical plants, then you need to use radioactive tracers if you have any problem in the process in identifying where the problem can be. I'm sure all of you must have been very closely monitored the Chandrayaan mission. It was there for 14 days. And after that, the moon daytime is 14 days for India and moon. So what happened was the 14 days, it had sun. And after 14 days, it did not have sun. And hence the solar energy was not working. And even though everything else is working, we are not able to utilize those things. And that's where nuclear batteries will be very helpful. The plutonium-238, which gives you heat, can be used for generating power. And this is being used for long space missions will be there. I'm sure all of you heard about Arihant, and then now recently the third one is also nuclear-powered submarine. Some of you must have seen a submarine. You realize that space is a constraint, space is premium. Almost like 2/3 of the space is occupied for the fuel. That restricts the space availability and also restricts the amount of time the submarine can spend under the water without being refueled. If you replace by a reactor, a small reactor, that would give you a lot of space and also a lot of flexibility in terms of time that the submarines can spend underwater before the refueling happens. And water is very important. Making water available is important. So what is demonstrated is called the extra heat that is being thrown into the sea. Normally, when electricity is produced, when the steam runs the turbine and the heat is converted, only 33% of it is only converted. Remaining thing has to be dumped into sea or into a river. So what is done here is the extra heat that is being dumped is utilized for desalinating the seawater. And in fact, there's a demonstrating plant that is there in Kalpakam, and you can see very economical way of producing these desalination water. In fact, this quality of these desalination water is so much, it can even replace a DM water which is used in the plant. And this plant is under operation at Kalpakam. Is nuclear, though we call it a nuclear desalination demonstration plant, essentially wherever thermal energy that is available that is being dumped into sea can be utilized for. So what it means is that a lot of possibilities are there, but there are some challenges. And what are they? Nuclear, and whenever you talk about nuclear energy to people, first thing comes to their mind is, what about the safety of the reactor? What will you do with the waste? Would it impact the environment? These are the concerns which typically you would experience whenever you talk about nuclear energy with the people. And hence, public acceptance is the most important thing when it comes to nuclear. And what we have done, we did some work at NIAS. What are the determinants of risk perception? One is catastrophic potential. That is, expected number of fatalities and losses are imagined to be long. There is a tendency to ignoring the lower probability of accidents and the relatively lower number of fatalities compared to other energy sources. But somehow we think it can be catastrophic. I just put some table here. I will not go into details, just to say different energy sources and what are the normalized fatalities per gigawatt energy. You can see it is nuclear is the lowest when it comes to this part of it. Coal and oil are very high. Hydro is also high because of the large scale replacements are there. And there are three major accidents that happen in nuclear. You can see the fatalities are very low. Though people think tsunami has killed so many people, but in Fukushima, there's nothing to do with the nuclear reactor. It's something to do with the tsunami that has killed many people. The actual number of people who were killed were about two people, and about 1,600 people because of the evacuation. So I don't need to say the fatalities in a nuclear reactor accidents are very, very less. But what about the other industry? You can see the type of deaths that have happened in other industries. Not only human deaths, you can see what happened in Bhopal and what happened in the expansion of liquid petroleum gas tank farm in San Jose. You can see the number of people that are killed are very, very high. And of course, why we want to worry about only human beings? You can also see some of the disasters led to a lot of killing of animals and seabirds. So these losses are enormous, and so we tend to ignore these things and pay attention only to nuclear. So there's a tendency of ignoring the lower probability of accidents, and if you don't pay attention to the detailing, you tend to ignore the facts. And the average perceived losses of average loss over a period of time, radiation-induced cancer resulting to death, whether future generations being born with deformities, disabilities, or health risk because of radiation exposure. There is no evidence of extended studies, including those who have exposed to high-dose radiation in Hiroshima and Nagasaki. You can see how the Hiroshima and Nagasaki is there today and what it was. There's no evidence that it is genetically impacting the next generation. Extended half-life of fissile material, yes, you can say these are all high. You need to take care of them many. You cannot dispose them. You need depositories. Yes, the work is in progress as far as the deep geological considered. So we need to see high-level waste management is concentrating. There's a three-step and immobilize them will be there. And India is very proud that it is one of the 6 countries in the world which has expertise in managing the high-level waste. You can just show pictorially, take from the high-level waste, convert them into glass, put them in a glass and store it in intermediate storage before we get a deep geological repository come. But we have the technology for mastering all these things. The synthesis of nuclear waste glass in the plant state, very high temperature process, India has mastered this. You can see about 50 and induction heating of and then convert them to a glass form. What I want to show here is that if you take a coal plant, the time for after shutdown of years is very low. When you go through a once-through fuel cycle, you require long years to take care of the waste. But if you are closed fuel cycle, you can see it is reduced to 400 to 500 years. And that means it is a reasonable time for us to manage the waste for 400 to 500 years. Is what it says. Radiotoxicity can be maintained when you use a closed fuel cycle. Now, having said that, what is nuclear technology? Nuclear technology is a knowledge-intensive, needs well-trained human resources, strong industrial infrastructure is needed. We need synergistic pursuit in basic research and technology development and multidisciplinary approach to problem solving. We require safety analysis encompassing the entire gamut of engineering and health. We also should work towards leadership development, research for achieving innovation, and the programs and starting new programs in the new domains. And there are 3. I don't know how much time I have. Do I have some more time? Yeah.
Yes, sir. We can.
Yeah. So I will talk about human resource because some young people who are listening will see. Typically, human resources are you have a professional level, middle level, and low level. And you can see professional level are scientists and engineers, middle level are scientific supervisors and technicians. For a 1,000 megawatt plant, typically we need a professional level about 30 of them, technicians about 80 of them, skilled workers are about 400 of them. This is what is required for a 1 reactor of 1,000 megawatt. And how nuclear education is taught? There are different models. The model 1 is teaching of nuclear engineering and technology at academic institutions, starting a bachelor's of degree level. Employability of restrict only to nuclear industry and becomes a severe restriction when the size of nuclear industry is small. It is practiced in USA, where the size of nuclear industry was big. being followed by Europe and in the recent times. The other one is take Bachelor's of Engineering and Masters of Science, given specialized education and training in nuclear engineering in-house in nuclear industry. That is followed by DAE and some other countries. And the faculty, the advantage of this model is the faculty are practicing professionals. Transfer of tacit, explicit, and implicit knowledge is possible. The third one is good masters and PhDs in academic institutions and further specialized in training in nuclear industry in-house. It is again the person with a higher qualification to uplift the standard of R&D in nuclear industries. Sai Baba National Institute is an example of such thing. It will be there. So there are different models which we can adopt for nuclear education. So those of you who are interested, BRC training schools are very robust process of selection. It's running from 1957. We also have an AMD as a for geophysics and geology people there. They specialize in almost all disciplines. 1-year course. It's employment. You're paid stipend, and after successful completion, you get employment and placed in one of the DA unit. And AMD it trains people in geophysics and geology. Of course, DA, those of you who are interested and got admission into IIT, you can always do that IIT MTech and then come back and join the DAE once you're selected. So there's a lot of opportunities for young people. There are also opportunity to pursue, in medical physicists for radiological safety and to equip medical doctors and use nuclear diploma in radiation medicine, diploma in medical radioscope technicians and nuclear medicine departments in hospitals. A large opportunities are there for people who are interested in be there. Well, it's very important to engage MSMEs. MSMEs, there are several issues with MSMEs. We need to address them, capital, human resources, cutthroat competition, but we need to involve them in our journey of nuclear. I would say that the academic institutions, the industry, and the MSMEs, they all have to come together if you want to address the challenges of achieving speedy growth of nuclear in this country. Well, there are problems and there will be problems. I always say it always looks difficult before you climb, and that once you overcome that, you will find that you will enjoy the problems which you face by climbing the mountain of sustainability. Well, this is my last slide. Direction is more important. I'm assuming that some of the young people who are listening, it will be impactful for them. Direction is more important than speed. Many are going fast, but maybe in the wrong direction. So this calibration, each of us have to do at every part of our life. Each of the organizations have to do it, and also the country as such as a whole should do this. Are we going in the right direction to meet our goal? So I think I'll stop here. I'll thank you for my attention. Feel free to contact me or at the details I've given here, and I'll be happy to answer any questions which arise there. So I stop here.
Yes, sir. So let us see if somebody can, or somebody is interested in asking questions from the audience.
Should I stop sharing or should I just continue?
You can stop if required, or I don't know, means it depends on question also sometimes if required, but it's up to
I'll
you.
keep it a while for a while, yeah.
Anand, Vinay, Anandita, is there any question with chat box? But you have put it up very nicely, starting with the quality of life and then comparing it with other resources. Perhaps I was reading somewhere India has signed one agreement where we have to reduce our carbon footprint by maybe by 2017, 17 to 0. So do you think, sir, nuclear power will be because at many conferences, even they talk about this, all others are having, do you think nuclear power is completely means having zero emissions or lowest one, and it can solve the problem or meet the deadlines which we are trying to achieve by signing these international agreements?
No, one is the international agreement is a commitment to to reduce the carbon emissions. Everything 2070, net zero emissions is what the commitment by everybody is doing. And how the net zero can be achieved is by a number of ways. One is to go for renewables like solar, wind and all. But I showed you some graph where 30-40% of the energy still come from carbon, from coal. So what I feel is that right now, the only alternate source that is available for replacing that coal is nuclear. And nuclear is zero addition to emissions during operations. That when it operates, it doesn't emit any carbon dioxide emission, and hence it adds energy and doesn't add emissions.
There is one question from Surya Rathod, sir. Is going to IIT important to get into nuclear industry?
What, I didn't miss you. What is that?
Is going to IIT important means whether the route to nuclear industry is via IIT only, or there may be some other sources also.
No, I think no, not necessarily. What we generally do, the training school system, I didn't spend much time on the training school opportunity which is there. People from any institute who are done undergraduate can appear for this part of it, but then they have to prepare well for this. And IITs, in fact, IIT system is not the only way, or not the major way. According to me, they should pursue the core branches of engineering, okay, core branches, and then they get selected, they get trained. I showed you 3 modes of developing nuclear human resources. Our model is you select people, train them, and then put them into the work. So I would say focus on your core branch of science engineering, and then I think you should also, for us, the selection process is very tough, but you need to pay attention to the basics. Okay. I think so. I would say not necessarily you. In fact, we mean BAE goes to smaller institutions also to encourage them to apply for this part.
So you can keep an eye, and they keep advertising. And BRC school is training school is one of the, I think, best way to approach this nuclear industry. Okay, there's one more question, sir, by Mr. Muralidharan. Are we into the manufacturing of nuclear batteries?
Yes, I think it's a good question. I think. See, maybe I would say yes. India produces plutonium-238. Okay, and it is available, but then the level of that production, the data I don't have. Yes, India has the capability of producing these nuclear batteries. When she probably referring to nuclear batteries, plutonium-238 as a source of energy. Yes.
I think that will be a good alternative to solve this problem of electric vehicles where you have very limited.
No, I think, and I thought, no, I would say a little different. Man, if you ask me at that question, that's a little far. What I say to you is that in the space missions, in the Chandrayaan, or other places where the nuclear batteries are used, and that is where I think the capability is there. We have not yet reached that level. Maybe I'll stop sharing so that we'll be able to do some discussion a little more. Yeah. No, I would only say to you that it's not reached the level where it's like very scientific imagination that I will have a small battery, put it in my two-wheeler and run. That is something which long way to go. What I showed you is that we are also looking in terms of microreactors, which are microreactors mean 10 megawatt and less than that. Okay, that means just imagine there's an industrial estate is there, multiple diesel generators are available. You remove all of them and have a small 5 megawatt reactor there running. So that's where the reduction in the size is up to 5 megawatt, 1 megawatt and things.
Maybe for smaller villages also that way, because
I think I mentioned you, one is the remote areas,
all those can be.
Connectivity is not there, remote is there, and things like that.
No, because of this, I know, because when I go to my village during particularly summer, every evening you have that thunderstorms and sandstorms, and at the end you will find either some pillars will be down or wires will get short circuit with each other, and then the whole night there will not be no electricity.
Yeah, I think. So I think I briefly mentioned to you these microreactors can serve multiple purposes. Remote areas where connectivity is not there, where the or calamities were there and there you need power. Many times you have seen whenever cyclone happens, a calamity happens, immediate thing is to restore power. You would see that there's a big struggle to restore power and then you follow. So these things will help deployable easily. Can you take it a small reactor and then try to provide power is something very imaginary, but then we need to work on the technology. In the technology in terms of cost, in terms of the cost.
Sir, I can see one hand raised by Ashwati ji. Ashwati, you can unmute yourself and then ask question.
Yes, sir. Good evening, sir.
Good evening.
Ashwati here.
Yes, Ashwati.
So, first of all, greetings to you, sir. I really enjoyed your lecture and your last quote, especially that the direction is important than speed, really motivated me. So, my question is, since I am a first year UG student in BSc Physics, so how can I improve my knowledge in this nuclear energy topics and seek for new opportunities, sir?
Yeah, good. I'm happy that you liked my last slide. I think it's meant for that for young people. In fact, it's meant for all of us at any age. See, first thing is that, if you are a first year undergraduate physics, what you should do is that whenever you get a vacation, you should see whether you can go do some internship with some of these research institutions. Okay. So that you get to know and firsthand what it is. That's one thing. Second thing is maybe you should do a master's. Okay, master's, and then apply for training schools. Okay. So I would say before you go to master's, every year you should do some project or some internship with some people to have a better understanding what really nuclear is. Okay. Many times understanding nuclear itself is a big challenge. So I would advise you are from which part of the country?
India, sir. Tamil Nadu.
Tamil Nadu. Okay. Tamil Nadu pakkathile Kalpakam irukku adula polam. Okay, so you can always interact with the people. The best way will be to know what you want to learn is what you need to do that part. So please visit maybe Kalpakam or some places and talk to invite people and to your institution to give lectures like this and interact with them and develop your expertise. I think most important thing what the people look at is not remembering things. It is understanding things is what is important to become a better researcher. Okay? Most of us spend time remembering things. So try to understand things. That is what your preparatory work should be to understand things. Okay.
Okay, sir. Thank you so much.
So just I will have, I think we are over with these questions from the audience. You mentioned about private sector opening public-private partnership in nuclear industry as well. Do you think there can be certain risk in that because technology going into the wrong hands with no control of that or going to the private hands? Do you see any risk in that?
No, sir. I think what we are trying to do is that the regulatory process will remain the same. Okay, that is the regulatory process will remain the same, whether it's government or private. That's why the government, what is done is first is government and public-private partnership, and then private. The three stages of expansion. So what is important will be to strengthen the regulatory human resources. You need to have, suppose you have 100 gigawatt means today we'll add 100 reactors more. You need to see the type of challenge that would have. So answer to your question is the regulatory process will remain the same. You take United States, the reactors are constructed by private companies, but they still go through the same regulatory process. So what is important is to strengthen the regulatory process implementation. And then you would see that, it will be there. Otherwise, you will become a challenge.
Yeah, without private intervention or investment, perhaps government, resources will definitely.
No, one is the investment for human resources, strengthening the regulatory processes and implementation mechanism of regulatory process. That means, suppose I have this regulation there, I need to, first of all, there should be a mechanism of ensuring that you are following the regulation. That's where
that is where I am sometimes I am afraid because in industry, there are so much of regulations which are already there, but many times they are not being followed properly, and then it becomes sometimes disastrous also.
Yeah, this apprehension is understandable, but what I feel is that there is already examples of how the US system works on private regulation. Okay, so we need to learn from those things. See, the problem in India is having a regulation is one thing, and ensuring the regulation are adhered to is another thing. Many times people think wearing helmet is for police sake. Many times the regulation is there. So I think your apprehension is genuine, but I think the government is not rushing. It is generating into 3 stages. In all likelihood, the public-private partnership and the private partnership can come with the whoever wins, the regulation will remain the same.
I hope so.
Excuse me, sir.
Because I remember there in Delhi there was, I think you might have heard and you might be knowing that also. In Delhi there was some scrap yard where the same thing happened, and there was some nuclear waste like which was dumped over there. So a lot of questions were raised around that. It's from where they get those kind of small. Though the intensity was very less, I feel. But it happens sometimes. So regulatory, yes, you said is correct. It's how you can maintain it and implementation is very good. Okay, I think we are done with this. If any Anandita or Vinay from my team, if any other questions is there, then Surya Rathod,
Sir, I have a question. Yes,
please,
sir.
please ask.
Sir, my question is there any limitation on the nuclear fuel?
The limitation means in terms of,
in terms of quantity and quality.
No, what it means is every fuel will have what we call it as how much of energy that you may extract it from the fuel at a given time. What we call as a burn-up. Okay, this burn-up depends on the type of fuel and type of the reactor. So once essentially in a much simpler terms, how much of fissile material that is available. If the fissile material is consumed, then you have to replace it. Or if more and more fission happens, you would also get more of fission products that are becoming available, and hence per unit quantity, how much of fissile material is available also will reduce, because in nuclear fuel, unlike other fuels, it is a fission product that accumulates along with the fissile material, and that fissile material density will come down. At that time, you have to remove the fuel. So these are some limitations in terms of how long I can use it. Okay, but there are, for example, at Kalpakkam reactor, it's gone up to 165 megawatt days. So it's a huge number it can go. So it depends on the type of fuel and also depends on the type of reactor.
Sir, do we have limited amount of nuclear fuel? How much amount do we have?
Okay.
How long can we use this?
Yeah, I think that's a very interesting question you asked. What India will have is that today we have, I showed you in one of the slides, we have indigenous fuel or imported fuel. Okay, India is now started importing fuel after the 123 agreement. India is now allowed to import the reactors. So a lot of reactors fuel is coming from outside. Okay? So that way there is no problem in terms of fuel availability because of the agreements we have with them. Whereas the indigenous fuel availability is less. That's where I think the challenge of finding more and more uranium resources in this country, and you would find in newspapers suddenly in Tumalpalli it has come, or in some other place it has come. So what I say to you is that India has got the technology to manufacture fuel and operate the reactors. The fuel input, if India is not there, we importing from the suppliers. So that way, I don't see a limitation. It was a limitation earlier when India was not permitted to import fuel from outside. Today, that restriction has been removed.
Okay, thank you so much.
Okay, then I think we can conclude with thanks to Professor Sai Baba for the wonderful lecture and putting things in a very nice manner, so that each one of us would have something to take home. Thank you, sir. Thank you very much on behalf of Nehru Science Centre as well as my parent organization, National Council of Science Fiction. I would like to express our sincere thanks to you and all our audience. With just adding this, that NCSM has already developed two galleries in its various science centers, which basically depicts about nuclear power, how they are called nuclear, all of nuclear power with the help of NPCIL and support from other like PRC as well. And now we are making one more for Jaipur Science Center.
Okay.
And the idea is that people should know there are a lot of myths which have been created about nuclear power, about radiation. So in those halls, we try to tell people that come and explore yourself and make your own opinion. That things are, as Sir has also shown in one of the slides, and that shows that till now, I think in nuclear there is only one accident so far, which is of means. So there may be some reason when they come across, but please do visit these galleries and try to dispel any myth and join this such kind of program where you can have direct interaction with the scientists or academicians, science communicators, and ask your questions on that. Thank you for being with us. Wish you a very, very great National Technology Day. Hope to meet you many more such lectures throughout. Here we have online, offline, on-site lectures. Keep joining us and stay connected, stay tuned with us.
Yeah,
Thank you very much, sir. Thank you very much, sir.
Yeah, it will be a pleasure to contribute if there is any required anytime. Hopefully, we'll get an
Sir,
opportunity.
if you happens to be sometime to in the Mumbai personal means on either somewhere or other, please let us know. If well in advance for when schools are open for us, we can have a face-to-face interaction also. It will be good for
Thank
children.
Thank you.
Thank you very much.
Thank you so much, sir.
Thank you. Can I leave now?
Yes, sir. We
Yes.
conclude this. Vinay, you can.